All right, so lesson 16, the factor theorem. So we've actually, like in the last lesson, have been pretty much talking about this. Just formally, though, the factor theorem states that xa is a factor of the polynomial if and only if p of a is equal to 0. That's really like when we've been throwing the numbers in to see if 0 comes out. That really is like the factor theorem there. So, so determine if x minus 1 and x plus 2 are factors here. So all we would have to do here, we just want to figure out, is p of 1 equal to 0. That's really what we're asking here, right? And p of 1, I won't make you write it all out again because we did that a lot in the last lesson, comes out to -3. So is that a factor or not? No, not a factor, right? That is a remainder. P of, so now the factor. Okay, so then p of -2 comes out to 0. So is a factor. All right. Now, this one's kind of written in a funny way. It says if p of 3 is equal to p of -8, and that's equal to 0. They're really just saying that, like, this looks funny, but this is saying that p of 3 is equal to 0 and p of -8 is equal to 0. It just means that there's no remainder on either of those. So that just says determine a second degree factor of the polynomial p of x. So we could just really write this as x minus 3 times x plus 8. Both those factors end up giving us zeros that come out to 0. Okay. All right, so now we can also look at the graphs and figure these things out, right? So when we're talking about potential zeros, I literally mean crossing the x-intercept. Or sorry, the x-axis, I mean, sorry. So we can look at the graph, and if we are given this polynomial, and they show us that, then the zeros of this, even without going to all the work of factoring this, if I got the graph, then I can see right there, and right there. Okay, well then those are my zeros, right? This thing has zeros at x is equal to -2, 1, and 2. Right? Those are just looking at the x-intercepts there. Okay, so then if it says what are the factors of p of x, then the factors are x plus 2 and x minus 1 and x minus 2. Now, could I just put all those together and say this equation definitely is x plus 2 times x minus 1 times x minus 2? You actually can't, and the reason for it is because technically this thing would look like this. It'd be p of x is equal to a times x plus 2 times x minus 1 times x minus 2. And we'd have to figure out what that stretch factor was. How would you find out that stretch factor from like the last lesson or last unit there? Yeah.
The y-intercept?
Yeah, we could use some point in the graph, right? We could use probably that point and say, well, that's the point 0, 4. We'd have to throw in zeros for our x's, and then we'd have p of x, we'd make that equal to 4, and then you have to solve for a. Okay, so it might be, like it might work out to be 1, but it might not. So it's just not always going to be the equation, but potentially it would be.
Will we have to do that a lot to solve for a or no?
Yeah, you would have to do that. Yeah, that is something that could happen, yeah. Okay, so which binomials are factors of this polynomial? Okay, so like we've been doing tons of this now, right? But I'm going to show you guys a method in your calculator, like because sometimes we have to check a lot. So can you guys get out your calculator and kind of follow along with me? And if you have a TI Inspire, it's going to be similar, but not exactly the same. Okay, so step number 1, I just want you to write out the polynomial. So it'll be x to the power of 3 minus, oh, not that. Just normally, yeah. Yeah, so you guys haven't done much of this. To the power of 3.
So for TI Inspire,
same thing, yeah. So to write it out. So yeah, minus 3x squared minus x plus 3. All right, so some people already said they pushed enter at the end of that, and they ended up like getting a number like 3 out. Like, what does that mean? I put a bunch of variables in and I got 3 out for this. What's happening here? Your calculator actually has x stored as a variable right now. You can actually put in whatever number you like. I could put in 2 for x, I could put in 3. So you have some number stored in for x right now. So we're just going to store a different number. If you go to store, which is, can you guys see where store is? I'm hovering over there right now, right there. Store on this one. Okay, so you would think that you'd have to go store and then the number you want to put in, but it's actually the other way around. You put in the number. So if I want to try out, like in this case, I want to try out x is equal to 1. Then I'm going to put in 1 and then store and then x. So it's putting 1 in for all my x's in this case, and then push enter. And I'll show you why this is going to be helpful, is because now I don't need to type this out every time. Now I can go up to x, or go up to the expression that I had, right? It's highlighted over that. Push enter. It brings it back down again, right? And now 1 is stored in for x. So if I push enter again, that tells me that like if all those x's were 1s, it would come out as 0. Okay, so I can say p of 1 is equal to 0. Yep. Okay, so why that's helpful now, right? Because like we would have had to have like put in like every time for all of these examples, we would have had to try it out. But now I can just keep on putting different values, like store different values. So for this next one, -1. So I'm just going to go -1. I'm going to store that in for x. So store for x, enter. And then I'll go back up to my polynomial. And then push enter again. And that, again, comes out as 0. So that one worked as well. So p of -1 is equal to 0. And then let's try -3. So I'll go -3, store for x, enter. Go back up and grab my polynomial. And then enter. And it comes out as -48. So p of -3 is -48. So that is not a factor. You guys kind of get, like, that's way quicker than it would have been before and way less likely to make a mistake. So just lastly, I'll do the last one here. I'll put in 3 for this potential 0. So 3, store for x, enter. And then I'll go back up, grab my polynomial. And then enter. And that one did work. So p of 3 is also 0. Okay, so then I could actually even just write this out as factors right now. This would be the same thing as x minus 1 times x plus 1 times x minus 3. It's factored, right? Those are all my factors. They have to be. Those are all my zeros. Okay. Okay. So now they just get a little bit tougher, where like on the last example, I was able to say, like I was able to just find them all, right? And it kind of worked out nice. But what if one of the factors was like 2x minus 1 or something like that, right? It gets a little bit trickier then. So we have some like ways to kind of work around that one, or to kind of work with it. So let's factor this one. How are we going to factor this one? Well, we know that our factors, like whatever they are in the end, like here, if I had, well, I'll just give you an example. If we had x squared plus 2x minus 15, then we know that, well, let's even just factor it. That'd be x and x. What would that be? 5 and 3, right? 5 and 3. Okay, well, I knew from looking at this that the number on the end, right, the two numbers here would have had to have multiplied to our constant term on the end, right? So even though that this is really confusing, and I've got a lot, right, there'd be a lot going on. If you were to expand, you know, a degree 4 like all 4 terms into itself, it would get really long and complicated. But either way, in the end, those constants need to all multiply together to give me positive 18.
So you just need 4 numbers multiplied by 18.
Yeah, so now this gets a little bit a little bit confusing because we're gonna have to figure out all of the different numbers. We're just gonna try them all out. This is why I showed you guys that last method, because we need to find numbers that multiply to 18, so the factors of 18. So we need to try out, so factors of positive 18. So that would be plus and minus. Well, 1 could work. 2 could work. Positive or negative, right? They could work out some way there. 3 goes into 18. 6 goes into 18. 9. And then 18 itself. So we got to try quite a few here, right, to make this work. This is where, again, like I said, like that last example we did, this would be terrible if you had to type that in every time to figure it out. So use that method I showed you last time there. If you try it all out, just keep on trying them to get our zeros, what you're going to get is you'd get P of negative 1 was equal to 0. You'd get P of negative 2 was equal to 0. And P of 3 was equal to 0. And then you'd try and try, thinking you made a mistake, because you're like, well, there must be 4, because I'm dealing with the degree 4, right? So this must be like, you know, something times something times something times something, right? There's got to be 4 in there. So I've only got 3, so something weird is going on. But let's put in what we have. I know that this thing is going to be x plus 1 times x plus 2 times x minus 3, and then I know that there's some last factor going on there, but I'm not sure what it is yet. Okay, so what would it have to be? Well, any ideas? Yeah, how do you know it's negative 3?
Because 1 times 2 times 3 is negative 6, and then negative 6 times negative
Good.
18.
Yeah, right here. All of these last numbers, whatever they are, they need to multiply to that last number 18, right, to make this work out. So the only way that's going to work out is if this is negative 3. So that one shows up twice, so we could rewrite this a little different. You could write this as x plus 1 times x plus 2, and then the x minus 3 shows up twice, so we're just going to say x minus 3 squared. Okay. Yep.
I know some. Do all the, like,
The numbers attached to the x, like the coefficients here.
or not the coefficients, sorry, the A value, I think is what you call them?
Yeah, like the a value here.
No, that's like, it,
All right, so let's do it again. We could have done that different ways though too. That was one way, kind of like this is kind of like a common sense way, I think, where we could just figure out what the last one had to be. But we can use synthetic division. We can use other things to kind of figure out what the answer will be. So in the next one, I'll do it a little different. And we'll kind of have to, because it's a little bit tougher when the number out front isn't 1. Right? Like this one was 1, so we were able to say, okay, just all the numbers on the end, multiply, give me this last one, but might not always be so nice. So, okay, so let's do this one.
Normally then divide them by 2.
What's that?
Can you do normally then divide by 2?
You could do that too, yeah. That's one, yeah, exactly. Okay, so we need to find numbers that multiply or are factors of 3. So we're looking for plus or minus 1 and 3. Are really it, right? So if you put this in, what you're going to get, you'd get P of 1, and you would have got negative 4. You'd put in P of negative 1, and you get 0. If you put in P of 3, you get 0. And if you put in P of negative 3, you get negative 84. Okay, so now what we've kind of done, we know that we know that this thing is, this could be written out as x plus 1 times x minus 3, but I don't really know what that last factor is, right? That's kind of the issue right now. Any ideas how we could figure this one out? And it doesn't work out, like none of the other numbers work out here. Yep.
Divide your polynomial by -1 or 3.
Right, yeah, so this one isn't going to work out so nice. I can't just go like my numbers on the end need to multiply to that last one there to figure out what that one is. It's going to be, like I can tell right now, it's going to be 2x plus or minus something, right? There has to be to get that 2 in front of that one in the end. But let's see what it is. So what we're going to do, let's do this by synthetic division. Okay, so let's put in just our original polynomial. And that would have, so on the first term there, it's going to be a 2, -5, -4, and 3. And we'll do -1 first. We'll divide that by -1. That's what we're really doing here, right? We're dividing that polynomial by x plus 1 is what when we're doing the synthetic division. So I'll bring down the 2. -1 times 2 is -2. -7. -1 times -7 is 7. -4 plus 3 is, or -4 plus 7 is 3. -1 times 3 is -3. And good, we got 0. That was, we did something wrong if we didn't, right? Because we said that it was 0. It should come out as 0 there, right? Okay, so now what do we got left here? So that right now, I just want to remind you what we just found there. This to begin with, this was my x to the 3, this was my x squared, this is my x, and that was my constant. Now in this case, this is my constant, this is my x squared, or sorry, my x, and this is my x squared. So as of right now, we've got x plus 1 times 2x squared minus 7x plus 3. Okay. Now I'm going to do synthetic division again because we can. And that's our new skill we learned. But anybody else see what else we could do just at this point? You could just factor that, right? Like you guys have the ability to factor when a is not 1, right? You could just factor that, and that would be your answer. You could do it that way. That'd be fine. I'm going to go on and just do synthetic division again. So I am going to now write this, right? This is my new polynomial. So I'm going to write 2, -7, and 3. And I'm going to divide that by the other polynomial I know comes out to be 0. That's that p of 3, or x minus 3, right? So we'll try out 3 there. Bring down the 2. 3 times 2 is 6. That's -1. And then -3, so it comes out to 0. So now looking at this, my constant term is -1, and my x term is 2. And that really is my last factor, right? So that's kind of it. So now we know from this that we've got x plus 1 times, and then this was just x minus 3, right? That's what that 3 was for.
So the last factor is 1/2.
Yeah, it could be 1/2. You could think of it like 2x minus 1, or x, yeah, minus 1/2 if you want to do it that way too. Yep. Good. Okay, I'll let you guys do this one. Okay, so if you guys do that one, trying out all the different factors for this one, there's a lot, right? You end up, you should get this, right? Okay. Moving on down to the next one. You know what? I'm not gonna do this one as an example because I actually pretty much did this example already, right? We got a secant, so that's like a rectangular prism. We pretty much just need to factor this because we need length times width times height, right? 3 factors. So if we factor this just like the one above, then it works out. So in the end here, this one's actually pretty easy. You can just keep on trying ones until you get it. It's going to be x minus 1, x minus 2, and x plus 10. So this would be your length, your width, and your height.